Good morning. The title of our presentation is Ancestral Techniques of Water Sowing and Harvest in Ibero-America, Examples of Hydro-geo-ethical Systems. On the side, you can see the authors of this work. They are the coordinators of different research groups integrated in a research network called Water Sowing and Harvesting. This network is financed by the Ibero-American Program of Science and Technology for Development. It is made up of a group of 66 researchers and technicians from Bolivia, Chile, Colombia, Ecuador, Mexico, Peru, and Spain. The network is open and multidisciplinary, including specialists in anthropology, archaeology, agronomy, hydrology, hydrogeology, and law. It is active since the beginning of 2019. Water sowing and harvesting, a term adopted from the Spanish language siembra y cosecha del agua, is a process used by man that involves gathering and infiltrating, sowing, rainwater, surface runoff, and hypodermic or groundwater to retrieve it, harvest at a later time and or place. This concept, as developed in Ibero-America, emphasized the ecological and environmental knowledge gained by our ancestors by observing nature over many centuries, a knowledge that has been transmitted from generation to generation up to the present. The objective of this presentation is threefold. First, to explain the concept of water sowing and harvesting. Second, to divulge through the centuries of Ibero-America the main techniques and sites where water sowing and harvesting is applied. And third, present the main hydro-geo-ethical principles underlying water sowing and harvesting as living yet ancient systems for water management. Different water sowing and harvesting techniques had been applied in the Andes even before the arrival of the Spaniards, and also in Sierra Nevada range in southern Spain, at least since the late Middle Ages. These systems have been built and maintained by local communities following their ecological knowledge. The new water sowing and harvesting that are being replicated in countries like Peru, Ecuador, and Bolivia are built respecting the beliefs, culture, and traditions of indigenous population. And in this slide, you can see the spatial distribution of these systems. These sites are located in mountain areas, mainly in Los Andes, where the annual recharge varies between 50 and 300 millimeters a year, and usually hard rock outcrops. The water sowing and harvesting systems are implemented almost on sloping aquifers, in which the managed recharge is retained due to moderate aquifer permeability. This is the main reason why these mountains aquifers are different from those highly permeable and transmissive aquifers. One of the most widely applied water sowing and harvesting systems in Ibero-America is that of cochas. They are natural terrain depressions that allow retaining rainwater or runoff temporarily or permanently. Their storage capacity may be increased by building ground dikes. Recharge through cochas increases the frequency and flow discharge of both nearby streams and spring located downstream. The tapes consist of small walls built in the main channels of some streams and rivers of discontinuous flow, trapping the water during rainy periods. They favor infiltration of water, which in turn can then be tapped downstream through wells or draining galleries. Another widely used system are the zanjas de infiltración or infiltrated ditches. They are lineal excavations in the ground forming channels with a rectangular or trapezoidal section. They are traced along altitudinal curves to intercept rainfall runoff to increase recharge while preventing soil erosion. The recharge water increases the discharge of both springs and drainage galleries, bukios, located downstream. In the photo, you can see the gallery built by the Pilla Matao community, which is located close to Cusco, Peru. For giving some data, the Peruvian Ministry of Agriculture has made more than 600 cochas and more than 600 kilometers of infiltration ditches in the last 2 years. Another water sowing and harvesting system are the bofedales or borreguiles. They are wetlands in which the man intervention artificially increases water recharge by enlarging the soil and water runoff contact surface by means of a net or open duct canal. As a result, both soil moisture and its spatial distribution greatly increase, favoring pasture growth, which are used to feed camelids in Los Andes and cows and sheep in Spain. The pre-Hispanic Amunas of Peru and the medieval acequias de careo of Sierra Nevada, southern Spain, consist of open channels dug underground. They are designed to derive the surplus water generated in the rainy season or during the spring thaw. The water derived from the head of the streams and the high spring flows through these channels and therefore infiltrating through the different stretches along the channel trace, particularly in those zones where the terrain is known to be quite permeable. In this slide, you can see the conceptual recharge model associated to the acequias de careo during the recharging period. In Spain, this situation happens along 2 or 3 months in a row a year. Most of the recharged water circulates through the hard rock weathered zone. On its way down gradient, many springs may originate. In Sierra Nevada, southern Spain, which is a small mountain range, about 80 kilometers long and 30 kilometers wide, a total of 730 kilometers of recharge ditches have been mapped so far. The researchers of our network are starting to publish papers on scientific journals, such as Nature Sustainability, Journal of Hydrology and Science of the Total Environment. We are demonstrating the hydrological efficiency, the social and environmental benefits, and the age of these ancestral integrated water resources management systems. Some of these systems are more than 1,000 years old. This slide represents how the inflows of the high mountain basins will change in the future, according to the climate change models, and how this will affect the hydrographs of the rivers. The snow peak and the base flow will be less than now, and the torrential rains will increase the variability of the river flow. However, if water sowing and harvesting is done, we will have more flow and even more constant along the dry seasons. Several hydro-geo-ethical issues are closely related with the water sowing and harvest, yet the foremost ones are environmental sustainability and human safety. Water sowing and harvesting represents a form of water management that allows improving the life conditions of humankind, reducing the poverty of population. These systems stand as a collective effort, with the participation of both men and women in the task of conservation, constituting systems of communal governance. On the other hand, water filtered through the ground may improve its quality, which is crucial for local populations. These systems foment the local biodiversity and the natural growth of pastures and other vegetation, as well as the associated ecosystems. The principle underlying water sowing and harvesting coincide with those pursued under the current paradigm of the integrated water resources management. These are the coordinated use and management of water, of the land, and of associated resources, with an aim to achieve a just balance between social and economic well being and the needs of ecosystems in space and in time. For this reason, we may state that the modern paradigm of management of water resources has in fact been carried out in some remote areas of Ibero-America for over 1,000 years. Many of the problems that affect us today have already been solved by our ancestors. Our goal as scientists is to recover that knowledge. Thank you.